Hello. Welcome, everyone. Should be working. Is it Samaria? Welcome. Doing good. I'm going to be doing some coding today. We'll start with a kitty check here. We have Sky in the tree, Ember across from the keyboard, Sammy and Mason on the bed, Sherbet in the play area. I think he's still looking for some lingering catnip. I got some of the good stuff recently. It's super effective. Let's see. That leaves Molly, and Molly is under my feet. Molly has required a behavior changes. I can't just move my chair around or roll away from the desk because she really likes to be like directly under my feet and will sometimes lay right against a wheel. So we must show caution. But yeah. We've got a lot of good objectives, I think, in the code recently, and that's given me like momentum, given me motivation, and I always need that. I always need that for coding. But how are you doing today, Samarium? Colliders. So now we want to go up here, and we are attaching to the entity added our main attach event. So we want to know when an entity gets added, but we also want to know when the game emits a physics step. Just so. So we need to detach from that. I feel that. Now, it might be apparent I did do a little bit of work beforehand here. Lots of comments and whatnot to get ready, since it ultimately amounted to me remembering what I did last time, doing that in advance. Okay, so we have a couple of things that we need to wire in. This is a collision happened. Let's go through the old model so I can show you what the pattern generally is. So entity added on a collision. So we have a source and a target entity. Actually, where's our event? Okay, so we have a source and target entity during our collision here. We check and see if we've already got that collision. During any given step, we only allow a entity to collide with another one once. And this pattern is ultimately going to give us a lot of flexibility in how we check physics, because we don't allow for duplicate events. If they stack up, they stack up. We don't care. There is some other nuance that we're going to need to deal with in that sort of circumstance and in general, but I think we're still good. If it's not already present, we add it in. So this collision collection is a dictionary to hash set, where we say this entity to these entities is the collision pattern. Then later in this, when we check collisions, We're going to go through that whole collection of collisions, and we're going to send messages to the relevant entities. This is amongst the things we need to make sure we're only doing when absolutely necessary, because this is one of the expensive ones. It can send a lot of messages. But let's continue here. So that's the general pattern, is we spool up all of the collisions as they come in from the physics server. And then when we go into our game loop, find. Sometimes people feel like changing their handle. The reason that the YouTube one annoys me is a lot of people make their accounts in similar way early on, and the ability to change that name is useful. From a technical level, from kind of a professional level, what it often means when they won't let you change a handle is that they are using that handle as a key in the database. And it becomes a big burden to change it when it's that way. You can, but it is usually essentially redoing everything when you change a core key. It doesn't mean that that's a certainty that that's what they're doing, but it's a strong sign that that is an identifying marker in the database, as opposed to there being a kind of background user ID, you know? So I get why that would be a reason that they wouldn't, but it also would require that before you went into this, you made a bad decision. It's effectively, when you sign in, you become user 5,604,000, you know, and you choose a name. The only time 5,604,000 comes into play is when you interact with YouTube as yourself. When everybody else looks, you're whatever you want to be named. Now, you could still have a suffix under it to say, this is user 5,604,000. So people could track you by that, could recognize you by that, if, say, you're a bad person. So you can't just hop names, you know? And you can still do things like block name squatting, block impersonation attempts. A lot of times this sort of like you have to use your account name stuff is used as they pretend it's for things like security and to avoid people kind of evading detection or doing impersonations. And it doesn't really work. Because if you manage to get the account in advance, then you're all set. Like, it's an uphill battle to claim that account back. Streamers run into that not infrequently, is that they aren't using a platform initially, and somebody gets in there and makes an account, which results in a lot of, like, the real and suffix usernames. You know, newtmechanist, no, I really mean it. This is the actual account. Those others are fakes. .com. We will need to wrap some of this stuff. But anyway, let's go to the game loop here. So we prep our messages. Camera handler is going to change eventually. This is vestigial. It's not vestigial. It's not what it's going to be. So we do our start step. We do physics. We say that time passes. And then we do our end step. Now, the physics step is everything that was caused to happen based on the last pass. We do at the top of the next pass. From a game flow perspective, from an order of execution, it is effectively You start, you do, you end, and then physics is resolved. Kind of. Because the start step happens before the physics step, but you know, we could actually shuffle that around, but generally start step refreshes everything. But because we now just have these 4 steps, we can change their order however we want with very little hassle. So we invoke these. So again, we will do stuff in this step. This is anything that has already been accrued. We'll do all of these things, and when we're done with the end step, when we're done with update debug here, we get to the whole end of this step. And when we come back around, when we exit this function, that's when all the physics processing happens. And that's why we do this near the start of the loop. Start step is really meant to be stuff that needs to happen at the start of a physics tick. Again, we might change this to be at the absolute top of the list, but we'll see. That's where we got last time. We got all that wired up. So this is, we know which one is the one that collided. We need to get the other one. So when we're looking for the targeted collider, we're looking for a collider in this. We're going to do by RID because with a physics server level collision, we have the resource identifier, not anything else. This is colliders.try get value collide with is out target. So, in general, if we can't get a collider from this, we're going to toss it. It is possible that a collider no longer has an entity. If that happens, we're going to toss it. Hey there, James. Welcome. We are really just getting started. We are actually looping back around to our physics server-based physics right now. Learned some things. We're doing this to try to strip off as much unneeded Godot architecture as we can. And then we're going to circle back around to things like wall avoidance and enemy avoidance kind of stuff. See how efficient we can make that kind of thing. Okay, if the target does not equal null, we are going to source entity is equal to if first we have to do this section. And we can do that here. And target.entity does not equal null. dot entity and entity target entity is equal to target dot entity. Okay, we have both of these. This is going to give us the ability to now check on collisions. Okay, so protected. Be a dictionary of entity to hash set of entity collisions. So first we're going to check and see, is this entity already there? If we don't have it, we're going to have to add a hash set for it. And then once we've added that, we're going to look at it and say, or if it was already there, we're going to look at it and say, does this hash set already contain the target? If it does, we already have that pair. We don't need it again. We could probably do this differently and have like a key value pair. Or just have a hash set of pairs of those entities. Can I get away with that? Pair is a... That would be a tuple. Tuple is a structure. No, it's a class. Okay, we can't do a tuple. How about a key value pair? Key value pair is a struct. Okay, we should be able to do that, because if it's a structure, its whole form is its identity. It's pure data. So it would be equivalent to an integer. I think. Because the thing that we're hashing is the pair. So source target. It is okay for a given source to appear multiple times. It's not just a dictionary. I think this will work, and it should be cleaner. source entity, target entity. Provider collisions, try. So it'll have to be a if not collisions contains error. In theory, this should prevent multiple collisions. We're gonna try an else. I don't know if I can get away with this particular structure. If I can, fantastic. So then during the physics step, I don't think we're doing check collisions anymore. Let's... Yeah. This one needs the physics step as well. It absolutely does exist. Yeah. Yeah. A physics step message. Step. Check. Collisions. We'll just do it that way to save us some hassle. And we remove the override here, and we go into our base collision manager, and we remove that. Yeah. we go. That'll save us some trouble. Each of these, we're going to do a thing, and then we're going to say collisions dot clear. Okay, we're going to do entity, source entity. Can just use this. These are two set operations, so they should be super duper cheap. Especially once compiled, but you know. If they're both still active. If an entity is removed, it goes inactive. And if we have a collision that involves either of these being inactive, we don't care about it. Let's make sure I'm doing this correctly. We know they can't be null because they got into the collection here. Okay, the source entity gets the message to say you collided with that thing. New collision message. Okay, we're going to run it. I should have built before I run, but we're going to run it and make sure nothing crashes because I just changed a lot of stuff. We're using the homing mouse currently to maximize rate of collisions. Okay. So we're going to run it in Godot because that will get us any Godot errors happening as well as recording if we're getting duplicate collisions. Which we will achieve by just absolutely flooding the world with these to see if we can get simultaneous collisions. So 9 frames per second at 6,000 things. Okay, we have some entities that are not showing. Like, we're getting some lingering shapes now and again. I don't know what that's going to be. Like, we're getting some collision areas up here that shouldn't be there. But anyway, we don't have any error states right now. All right, so now we're going to prep our collision manager. We have our collider node version. We are going to make a new scene for the physics server collision manager. That is a node 2D because it needs to be in space. Actually, hey Jay. Great deal of traffic and very slow. Welcome, welcome. This can actually be a... this can just be a node. There's a reason that we want it to be something like a node, is it doesn't need to exist in space, so it doesn't need to get a lot of like physics messages or anything like that. It's small, but if we use too many node 2Ds when we don't need them, then it can lead to problems. Okay, and then this, we are going to attach a script, which should be that CS that we've got, which we've already got there. We close this because we don't want to keep reopening it. And then we go up to here to our default startup resource. And now we begin the real breaking of the things. Pile. We run. We start. We explode. Okay, that's why. All right. Because the node-based one has to be a... unfortunate. The node-based one needs to be the parent of a bunch of nodes. At the moment, I think it needs to be a node 2D. I don't think that's necessarily true. Like, I could make Collision Manager be a node 2D. But for the time being, let's just skip that. Okay, we are getting some graphical anomalies. Nothing is happening. That's bad. We look over here. We are generating errors at a very high pace. Unable to cast object of type. Oh, okay. Well, there you go. Missed that. Interim code go. Okay, this is where we're going to get a collider. We're going to take that collider and we're going to initialize it, but we're not actually going to do this. It's always going to be a collider key of this. So let's say string key, collider key, so entity.catalog name. This will be relevant later. Okay, so this is what should happen. Instead, we're going to add a little line here, is equal to... well, this is what will ultimately happen. I really want to be able to cache it. But we still can. We still can. Okay. Hacky code go. So the collider cache is still going to contain this name. But the thing that it produces will always be a particular type here, which is going to happen here. Physics server collider area circle. Hey, Jordan. I don't know who that is. The cats are doing well today. Sky has been a little bit hyperactive, and he can get a little bit over-aggressive when he's hyperactive. But otherwise, everybody's been good. And we are, in the game, we are working on an alternate take on the physics system that should be more efficient once we get going. Collider as this dot radius collider area circle has a radius. Yep. Not a program or media that I'm familiar with. Sky is just sometimes super active. He'd be like that sometimes. I'll short circuit this. So this is what we would actually do. Let's see, circle. Just so. And then circle dot radius is equal to 10, just to make it real visible. Okay, this should make every collider that comes in have this type. No matter what, we always get this type. Stuff is still moving. Collisions are not happening, though. Let's look at the errors on the Godot side. Reload that from disk. We're going to close this. We're going to go over here. Because I really don't want you doing that. Okay, we're not getting errors, which means the actual collision process isn't firing properly. So we're looking into collider collided, and then we're also looking into physics step here. Okay, we're not even getting the collision message. Noted, noted. Collider area has its area monitor callback in our Godot object. I never wired it up, did I? Oh, no, there it is. Good. We initialize, we create it, we give it the root ID, so that is the area. So next we're going to look at, within this, we're going to look for this happening. Oh, thank you for the follow there, Jay. Okay, we're never getting the call back. Never actually getting to some of these. Attach the collider events. We are looking for collided in and that entity being removed. We set the entity in the collider. Well, that's not going to help because collider area doesn't seem to have any proper updating for actually... Oh no, we should have an update collidability being triggered. Move the events, set the entity, update collidable. Update collidable in an area. Call the base. Say if the entity is not null, then we're going to set that it's monitorable, set its collision mask, and set its collision layer. So what it's looking for... Okay, we're going to go in here, and we should immediately see this fire. Okay, and the entity is the player entity. We are collidable. We don't collide with anything else, and our category is 1, player. So now our entity is this is our wind-up mouse. We are collidable. We have a category of 2. We are a bullet, and we're looking for the enemy category. So monitorable should be true. Okay, let's look at this on the Godot side and make sure we're not missing anything. So we do have the area debugging on, but because... Okay, we don't have areas being added to these. So if you look, there's a collision box on this. Actually, that's not a certainty. This is a node collision here. So that has a known area. Okay, we've just got to step through this whole mess, and we're hunting for where things aren't set up. Okay, so we are setting up the callback. And we're getting that area, which for reference is 564788. Let's make sure we keep track of that. Collidable and an area right here. Okay, this is the same one. It is the same area. 564788. What was that? I think that's the same one. Look at the Godot side and look at the physics objects being created as we go next. Well, we know they're being set up here. We know that we've got our call to create the callback happening. And we also have our area monitor being called. Them run into stuff. Now it's possible that our short circuiting here isn't working. Let's take a look at that and make sure that we are actually getting into here. So we're getting an RID. We set its data, which is the radius, which is always 10 in this scenario. And then we add the shape to our area here. 1994242. Okay. So they should exist. I don't think I'm missing a step in that process, but we are not getting collided events raised. We are not getting our this is not happening, which implies that maybe the space isn't being set properly. Just a moment. Okay. Initialize with space. This right here should be causing our immediates here. This is an invalid world ID. This node doesn't get a proper space. That's going to stop it from working. Hello, Tass. Okay, so how are we not getting... already part of the world by the time we should get our first physics step. Let's go here again. I want to see what we're getting as far as... might be like old documentation that's biting me here. Okay, so we're using a different property here. Okay. There we go. Okay. Okay, we need... yeah, right. This shouldn't be possible. Should not be possible to get a source entity of null here. His source entity, it can't collide. Okay, let's look at our pairs here. Ah. We aren't checking that the collider's entity is yeah. So we have a target collider. Source collider. Well, we are doing a null check on this one. The problem was it was the source that was null, which means this coming in had no entity. which would mean we collided with a collider that had had its entity removed. It was detached. And if the entity was removed, then it should not be collidable. So we still have all our monitoring stuff. We have update collidable. And in our physics server collider, if the entity is removed, we set the entity to null. If we set entity to null, we detach the events. Entity is null, we're going to update collidable. Area, when we update collidable, I'm going to call the base, which is going to do nothing. And we're going to say it's not monitorable and it doesn't look for anything to collide with. Might be other tries that I'm doing, but okay, collisions. Hello, Mason. Make up your mind, bud. Make up your mind. So if source collider in that case is null, then it will also report false. Okay. So if this is null, then the condition is false. Okay. right there. How? It implies that this one had its entity removed. Nuke it there. So then we're going to go into our collider. And we're going to do this. I want to see if this is happening. I want to understand the order of the events that are happening. We are getting a null before we're getting the collision. This entity is being removed before the physics step, which is in the start step. Which could result in the collider removing itself, which could result in a collision being invalidated. But how did it get there without a collision being recorded? How did we get a remove this entity event without us having an intervening collision? Are we properly tracking this? Because we got that other one first. Entity removed gets called. Let me go through the daisy chain here. So entity removed only gets called at the top of entity manager. And it will remove any entities. It will cause the chain of events that remove an entity. If that entity has been flagged for removal during the prior step. But right now, there are only two things that remove entities. That is, it times out in its behavior step, or it leaves the radius of that it's within like 2 screens of the player kind of thing. If it timed out... Hey, Lore. So during its behavior step, it times out. It is queued for removal. But it existed in the world before that. Okay, let's... So let's say in one physics step, an entity times out. But during that step, as part of its timeout, during that moment, it did collide with something. That would mean that at the top of the start step, which happens before physics, we would remove that entity, and the event would daisy chain out into the colliders. And say all the collisions for this entity are invalid because it already is getting removed. We could mitigate this in two ways. Right now, we're using one like master hash set and saying that these colliders, these entities are the thing. But equally accurate would be here. Would be when we're parsing the collisions in our physics step. So we're iterating all of the over the collisions, and we have the two entity pair here. So if I were to say, if both of these entities exist, so apparently we can't end a bool check together like that because it would be null or otherwise. We can just do this. So effectively, if during the behavior step, an entity has been flagged for removal, but there is a collision on the books for it, if we get to the physics step here, we are going to ignore that if any of the entities in it are null. So they have been previously removed. I could also do some logic to prune this collection by changing it into the same model that the node-based one uses, and that's that it is a dictionary of hash sets of targets, but that doesn't protect us from the target going null. So I think this will protect us here. It is still possible that this happens. And in general, yeah, during our physics step, during the behavior step, something gets removed, but it doesn't get physics removed. Does it? We ever removing it from colliders? So that step is still good. We don't... We never remove it from colliders. Which means it can be found even if it is because when we get a collider for the entity, we are going to add it to colliders. do this, then it's not in a list of active colliders, which means when we go to get it, it isn't a valid one. More mice. I am seeing... Oh, yeah. Burst is a... If at the time, like, if the projectile as it is emitted immediately hits an enemy, then it can negate the ability for multiplying to happen. But we do need to watch out for that. We don't want extra collisions to be recorded with inactive entities. Because if we do this... Okay, it's the nature of burst that was doing that. Okay, now we are going to go over to the Godot side and verify that stuff is working. We have no errors being generated. We flood the world with homing mice here. Homing mice are set up to acquire a new target if they lose theirs. So that's why they kind of like spread out that way. Now, if you'll notice, our performance right now is actually a little better. We're at about 7,000 things, but we have 12 frames a second. That is about 4 higher than I would normally expect. We do have some sprites that are not being loaded. I saw an orphan shadow there. Just for giggles. This makes them have a harder time tracking or reaching their target, but it's not too bad. We'll get a nice wavy motion with this. But we can even just see some of this with much fewer. Or is it much fewer? Exactly, Jay. It's the fact that the frames per second get so low when that's happening. I'm not worried. Because if you're getting killed during that, then you have already reached some sort of like roguelike difficulty escalation. That it's because a projectile effect tagged you through the mob, you know? And I don't plan on having a lot of the try to dodge things aspect. I would rather just throw more enemies at you or something. Exactly that, J-Wing. It's you are winning. It's the game is really slow right now, and it's because you can't lose. But even in this state right now, this is a 1-to-1 thing. If I make it so the blobs can soak a hit, then it changes the equation. But this is 9 projectiles per second, 1 enemy per second. The enemies are wiped out pretty steadily. There are all kinds of knobs that we can turn for this, but this is pretty solid. Okay, so we're going to switch back over here, and we're going to get our debugger. We're going to get our monitors, and I want to look video physics. We have collision pairs. We have no active objects listed. So this is where we are right now. There's not a lot of collision happening. I believe these islands are going to be essentially physics objects that are sitting off doing nothing. They do kind of relate to the pairs. But let's... and that. This will create some interesting behavior because the behavior of the mice is to push towards their target, whereas the behavior of the spiral is to keep them in that outer radius. So we will occasionally see the edge of the spiral kind of bulge out to hit an enemy, as the ones targeting that enemy kind of push in that direction. Yeah. This is actually an improvement. We done good. Let's make it even wonkier here. Yeah, the inward spiral motion, Jay, is kind of a gravitation. It's that movement behavior is actively pushing them to be at this radius. So we can see they're kind of spraying out a little further, and it is costing us some frames per second because we've added another layer of behavior on top of everything. But they push out of the radius because their movement is kind of a metronome right now. Is even if the spiral is saying move towards the edge, that move towards the edge is every second is moved by like a 45-degree offset left or right. Kind of tick back and forth. It's more emphatic than the back and forth loop is. Can also do this. I completed an objective. I'm just going to mess around for a moment. Okay, so we're saying that after 3 seconds, begin the spiral motion. I have not, James. So because it takes 3 seconds for the spiral to begin, we're seeing that we have a much stronger. Thanks, James. It's always interesting to look at that kind of thing. We have a much stronger kind of death ring forming here. Because they're already outside of the spiral by the time it happens. So in general, they are pulled back in and then held at that radius. Let's make some fewer of them so we can potentially see it. Part of what we're demonstrating here is the behavior system. The idea that all of the movement in the game is building blocks. So the fact that the mice home in on targets, that they move at a particular rate, that they home on that they orbit, that they do damage, all of that is happening because of like little plugins that you stick on them. In particular, the mice intrinsically home to a target and do damage on impact. That can't be changed, but after they do that, after they say lock onto a target and move towards them each tick, then we start doing all of these other things as they come along. So if I put the zigzag here, they're going to continue moving like this until they hit this point. So they start out zigzagging, and then the spiral begins. So we've got a much more irregular orbit around it now, because it has 3 seconds to get into a weird position. And then they get hauled back in. But if we say they start zigzagging after 3 seconds, then we're going to get our anime cluster missile waves coming out here. And then after a period of time, they're going to start moving back and forth. So we'll get we get kind of a strange cloud. The homing nature makes it a little harder to see because they don't stay far away. They keep going. We could change that. We could make it so that they don't reacquire targets. That once their target is gone, they just keep moving in the line that they were going in. But for now, that's what we're doing with the wind-up mouse. I am still seeing orphaned shadows, which means that the sprite for the blob has been removed, but its shadow remains. Or that the sprite was never added properly. This is strange. But some of that is likely due to rendering anomalies there. There are aspects of the rendering that I want to move over to a server model, where instead of building things the way I am currently is to actually go in and say, I'm just going to make a canvas. I'm going to make a sprite on it, and I'm going to populate it in this fashion. Some of the things I'm doing should still work as part of that. The complexity goes up, but it gives me very granular control of that process. We'll see if we get there. But progress on this front. Progress on this front. Okay, let's make sure I don't have any more debugging stuff lingering. I don't need a spacing change to go through by itself like that in a file. One of the things that we'll do next is to finish up all of the different shape objects that we're creating. And words and things. Once we've finished up all of the shape objects, we can start updating the catalog so that we don't have to use the workaround of everything's a circle. Technically saying I'm transitioning to physics server collision is inaccurate. You're always using physics server collision, but I'm using it directly. Okay, so right now we don't have all of the shapes that we're using. We need to add capsule as well. It's vestigial in capsule. That's going to be a problem, really. Yeah, we're doing this twice. This was for when the body was here. I don't really need to change this. We're moving away from this logic, but I don't want to leave, like, vestigial code in it in case we have to fall back for some reason. Really hope we don't have to. The other advantage of doing a custom, like, rendering solution is that it will make it easier for us to do the caching that we're doing right now. While there is some upfront work to do on those objects, since we're messing with them directly, it can be easier to adjust them on the fly and just keep them around. So, you know, I stopped drawing it and we can then move on to, well, I'm sorry, I stopped drawing it, but all of the details about what I put into the drawing are controlled by, like, directly. So I don't have to make a sprite and set all of its animation frames, thus, like, recreating a lot of Godot objects. It's, once I get in there, it's like, okay, I have this texture. I am cycling through that texture. And if we get extra fancy, we can just slap shaders on things and say, do the sprite animation thing. We'll have to see. There's fiddliness if we want to add shaders as the primary draw method, since that removes shaders as a easy add-on to the entity as an extra layer over it. Then you need kind of layers on layers to get shaders over shaders, and it's trickier. But again, we'll get there when we get there. For now, we need to add capsule, because that is really the other shape that we're actively using. It is not the best shape to use by far, but it is visually easier to map it to what is in the game for a lot of things. So like most of the bullets are kind of a offset circle at most. But like the player, their hitbox is their hit zone is a capsule around their feet. So it's, you know, kind of a squashed circle around their feet, and that's where the bullet has to hit. And that creates that sort of pseudo 3D, and that something can approach behind the sprite without immediately hitting it as soon as it overlaps the top of the sprite. Does it have to be that way? No, but we're still going to end up using capsules either way. Because a circle, especially with like, you know, tall entities, so a humanoid creature, tend to be taller than they are wide. And if you just try to use a circle there, a single circle, you end up with a big gap on the sides that is counterintuitive, like visually. Like, why did that hit me? It was off to the edge. So we are going to duplicate circle. And we're going to rename you to capsule. I've got a bunch of partial classes. I don't really like the idea of the partial pattern at the moment. If I start using it, I can start using it. But that will be a deliberate choice somewhere. I don't want to take class functionality and break it across files unless I find a real good reason to do it. Okay, so we create a capsule. Height and radius. Okay, so that is, we have set. So instead of just passing radius here, we are going to capsule height and then radius. Is there a real good way for me to set? I have rotation currently. Because if I do this, capsule is vertical. So can I, when I'm messing with... transform. We're just going to it's going to be hard to tell if we do it right. But we'll be able to test it. We'll be able to test it. Okay, areas are going to have a rotation value. Don't have to JSON ignore non-properties, but we do just to cover our bases and to indicate what we're doing. What is it? We have that somewhere. Spawn points should have that. Spawn point, spawn around player. No, we're not getting a math f dot degrees to radians. Okay. F dot degrees to radians value. Now, I could start off rotation in degrees and radians so that it is potentially cleaner, and both of them just have a return of what they are and a similar one, but this is really only relevant internally. From a file perspective, I'm going to use degrees. Handler. Go. And in capsule, we need to make sure that we get that into the constructor as well. Otherwise, we'll lose those. Or otherwise, it won't work right. Okay. Then, if in the manager we say that this is an area capsule, and it's still collider key, and it's .96 is generally a square. Not really, but so 192 will get us like double the width of the area. We're going to rotate 90 degrees. So what we're looking for here is that things are able to collide left and right more easily. Or sooner than they should. Just for giggles here, let me check what our settings are in Godot. Scaling factor is 3, so we're going to use ×3. It's a magic number right now. It's not going to stay that. This whole chunk is for debugging. Okay, that's still going vertically is the primary hitbox there. We are getting some odd behavior out of it. rotated. Related to position. Shame I can't see the collision zones in Godot debug if we're doing it this way. Okay, transforming it that way doesn't work. Okay. The spatial math on this is different, since it's not doing anything for you here. Okay, no, that's doing what we want it to. Okay. It's times 3 out of there. Collision manager when we're setting it up and we're hard coding what it is. So you can see a little bit of wiggle with the collisions in this case. But overall, that's working. And since we have capsule now, we are able to go into our data. Look at our colliders. And we're going to replace these collider nodes circle with, well, we're going to replace each one with its relevant bit. They're very wordy, but, you know. The reason that they are wordy like this is that, how to put it? There are going to be physics server. It's entirely possible that there are physics server colliders that are not areas. So this capsule. Just so. So now in our manager, we're going to hop back down here and we're going to remove this hard coding logic. Just so. Again, we don't need to set this, but here we are. We're going to go over into the Godot side and we're going to run it so we can see any errors that are generated, of which there are many. Can't cast a player entity into a collider. Well, that's just entirely wrong. Oh. Oops. I remember seeing that in the debugging. Okay. So the size of that is off. So let's look at a scaling factor. It's during initialize that we're doing it. Resource.scaling factor. This is one of the areas that I want to make cleaner. Is this should just be a global reference. It's what's the scaling factor. I shouldn't be hopping through this. During the configuration, when we use this, I should be setting the static value to the scaling factor from the startup resource. just like during the startup, I should be saying, whenever anything in its initial its construction needs the game object, this is what it's going to be, kind of thing. Okay, but we have our scaling factor here, and in the node version, when we initialize, where are we using that? Yeah, we're setting the scale of the area here. So when we're creating things, so in our collider area, we have access to that. So when we're creating the area, do we have an opportunity to set up its actual scale? So we have shape in it. And what about here? We could just multiply out here. So times like scale like that, so that whenever we use it, we are using a multiplied out version. Still very much direct hit territory with a lot of this. So we know we're in the right general spot for them. What are those set to? Bullet game data. Wind Up Mouse is using an 8 size capsule. And the Yarn Ball is also using a capsule of size 8. Means it's 8 wide. I could have an offset circle, but that's tricky. Like I said, we're getting collisions. This'll do for now. That'll have to do for now. We will need to make sure that the colliders are big enough that it is intuitive that they're going to hit things. Right now, the mouse is not. So if we were to instead... Is that better? It's going to have dead space around it that it can... that we can run into issues with. Even worse at hitting them that way. Let's use 16 on it. I will have to figure out how to do this correctly. But let's see. Let me see here. What else? We are going to halt for the day, I think. It's a little early, but I need to think on some of this and figure out what we're missing in the collision right now. I know, at least with the mice, that the collision is weird because of the positioning. The mouse is longer than perhaps it should be. At least it's centered on, like, essentially the butt of the mouse, like right at the tail. which alters the way that you would perceive the collision. It should be the center of the body of the mouse, which will mean adjusting the sprite such that it is long, to create it such that will create dead space at the front of the mouse, but it will mean that it rotates differently, and that's further review needed kind of stuff, because we don't want it to pivot on a weird center when it rotates. But that should be handleable with sprite offset. Again, we'll see. Oh, but I hope you had a good time, folks. If you like what you saw and would like to see more, remember to like, comment, subscribe, all that good stuff. Most of those buttons are good things. Press them to help the channel grow. If you'd like to consider financially supporting the channel, you can do so through on-platform means like memberships and subscriptions, as well as through other options available through the LinkTree in my profile, my Twitch bio, and YouTube video descriptions. With that said, though, I hope the rest of your day is good, and I'll see you next time.